Great. So you've probably heard about the three R's for much of your life, where you know reduce, reuse, recycle. And the first two are pretty straightforward, right? You reduce how much you consume, you reuse when you can, and then you recycle. That has a little bit more mystery associated with it, right? You put a bunch of stuff out on the curb, and all of a sudden it becomes other stuff. How does that happen? To answer these questions, I'm here. I'm Luis Melecio-Zambrano. I'm a student at Cornell who studies fast rate batteries, and I also do science podcasting. And Shelby is joining me.
Hi, yeah, I'm Shelby. I'm also a grad student at Cornell. We work on renewable plastics, and so I'm super excited to be talking about recycling with you today.
So what is recycling? According to the EPA, is the process of collecting and processing materials that would otherwise be thrown away as trash and turning them into new products. So that sounds great off the bat, but what are the reasons we do this? And there are two main reasons. One is we save a lot of resources. So paper comes from trees, plastic comes from oil. We have to mine to find the resources for glass, for steel, and all of these have some associated downsides, right? So oil, you risk oil spills. There's a lot of mining can cause pollution and environmental destruction. And so these seem pretty straightforward, but one of the things you might not think about so much is the energy savings. So the amount of energy required to create these new products from raw materials is pretty significant. And that energy, of course, converts into carbon dioxide. And when we recycle, we save a huge amount of that energy and thus a huge amount of this carbon dioxide. So it's not just a resource thing, it's also a direct climate change thing. So how do we get these benefits by recycling? Well, in the United States, we start with what's called a single stream recycling. So everything that you might want to recycle gets put in a bin, and that bin gets taken to what's called a materials recovery facility. And what those facilities do is they clean it some and separate all our different recyclables. And this is kind of where the recycling system branches off. So if we're going to follow one of those branches, let's follow glass. That glass is taken from the materials recovery facility to what's called a cullet processor. And what that cullet processor does is it crushes and cleans this glass into what's called cullet, and it sorts it according to color. And how it does that sorting is it shoots light through the glass and measures the colors of light that come out. And by doing that, it can see the color of light and sort it. And the reason that's important is because all of these different types of glass have different chemical additives, and you want all of these to be pure so that they can be recycled into new products. And these products, when they're recycled, have the same quality as the glass that they came from. And this is something cool about glass, is that it's what's called indefinitely recyclable. It can be recycled again and again and again with no loss in quality. The same is true for aluminum. In aluminum, once it comes from the materials recovery facility, it's cleaned and it's shredded and it's melted down. And when it's melted down, a small amount of the aluminum reacts with the oxygen in the air, and that becomes aluminum oxides called dross. And this has to be removed. And so these large steel scrapers come and remove those impurities. But once those impurities are removed, you can cast these into ingots, and those ingots can then be turned into sheets, which can be turned into new products. Steel is actually quite similar, but steel is covered with a layer of tin. So if you've heard of a tin can, it's actually a steel can covered with a little bit of tin. And so that has to be removed before it can be recycled. And so that's cleaned off using a very basic solution. And then similar to aluminum, it's shredded, melted down, cast into ingots, and then rolled into sheets that are then usable by manufacturers. for paper and cardboard, it's a very different process, right? We can't melt down paper and cardboard. So what we do is we form a pulp, and this pulp allows us to separate all the impurities out of the paper and the cardboard. And once those impurities are removed, the water is pressed out, it's dried, and they're able to take these, send this new paper to manufacturers, and that can be reused. But unlike aluminum or glass, these aren't indefinitely recyclable. And I've kind of been hinting at this, but I want to go more in depth into that. So aluminum and steel, right? Those are made out of elements. For steel, that's carbon and iron, and for aluminum, it's just aluminum. And if we have an understanding about elements, that you can't change them through physical or chemical means. So what you can do, you can melt them down and cool them down again and again, and you're not going to change how those elements are or what they are. Glass is made up of silicon dioxide, which is a chemical, but the bonds between the silicon and the dioxide, or the oxygen, are so strong that these won't break down over time. So you can cycle and recycle this indefinitely. The same is not true for cardboard and paper. So these are made up of natural fibers called cellulose, which are found in the cell walls of the trees that this pulp comes from. These long fibers in the pulping process are separated so that they can be cleaned and repressed. And when they're pressed back into paper, the bonds between the sugars that make up these fibers break sometimes. And so you end up with shorter fibers. And when we have shorter fibers, they can't wrap around each other as much, and that means they are less tough. And what ends up happening then is you have a lower quality material than when you came in. So if you started with really nice printer paper, you might end up with newspaper quality paper later. For paper, this is less of an issue because this is made out of cellulose. Those celluloses are made out of sugar, and sugar can eventually be composted or digested. So like this, after it's found its use in paper, can find its way back into the environment. The same is not so true for plastic. And so to talk a little bit more about why that is and how we can successfully recycle plastic, we have Shelby.
Hey, so before I even start talking about the recycling of plastics, I want to look at plastics on a molecular level and see what's happening there. So if we zoom in, we'll see a really long winding chain. And it's not just one chain, there are multiple chains. Sorry. Oh no. I'm so sorry, guys. There are multiple chains, and this creates regions that are called amorphous and give us soft or flexible plastics. And if the chains are more ordered and in line like this, more like bricklaying, this is called crystalline and gives us hard or rigid plastics. And so in reality, plastics are usually actually a mixture of these, where there are amorphous regions next to crystalline regions next to more amorphous regions. And the amorphous regions give plastics their really great soft, flexible qualities, whereas the crystalline regions give their toughness. So you have a plastic bag that's really nice and flexible, but can also hold all of your groceries. And if we zoom in further onto these chains, we'll see that there are units, and this unit repeats to create your chain. This one unit is called a monomer, and when those monomers are chemically bound to create chains, they're called polymers. And the composition of the monomer is really important to the identity of the polymer and therefore the plastic. So monomers can be composed of things like carbon, hydrogen, nitrogen, and oxygen, as well as chlorine and so many other elements. So when that composition changes in our monomer, that changes the composition of our polymer, and therefore how those chains interact and assemble with each other. And this gives us all the different plastics we have with so many different properties. And so if we go back to recycling, if you've ever looked at the bottom of a water bottle, you may have noticed the recycling symbol with a number in it. And 1 through 6 represents all different types of plastics. So all 1 is PETE, all 4 is LDPE, whereas 7 is all other plastics. So this means that they all have different monomers, that when they make polymers, those polymers all have different properties and give us different plastics. But if you notice, these two, HDPE and LDPE, are actually the same monomer. So it's not the monomer that's giving the plastic its different properties, it's the structure of the chain. So HDPE has what's called a linear chain, where it's just a straight chain, whereas LDPE has a branch structure, which means that there are chains coming off of that main chain. And so when these chains try to assemble, the linear ones can get really close to each other and pack nice and tight. Whereas the branch ones, when they try to assemble with each other, the branches get in the way and make it so there's more of an amorphous quality, whereas linear can get those nice crystalline properties. And that is why HDPE stands for high density PE, whereas LDPE stands for low density PE. Because in HDPE, the chains can get really close, whereas in LDPE, they have to stay more spread out. And so by changing the monomer or the structure of the chain, that's how we get different types of plastics with all different types of properties that can be used for so many different types of applications. So now we can go back to the recycling of plastics. And so we're at our materials recovery facility and we've just removed all of the glass, paper, and metal. So that leaves our plastics. And before we can start recycling our plastics, we must separate them. And this again goes down to a chemical reason that because we have all these different types of monomers and the structures of our chains are different, they all have to be recycled in different ways. So in order to separate the plastics, it can be done by hand, or it can be done with a machine like this, where the plastics come down onto a conveyor belt, and then they pass this infrared light sensor. And if we examine that, we have to look at where infrared light is. So this is a spectrum of all the lights we have. And in the middle, there is visible light, which is the light we see, ranging from red to violet light. And infrared, or IR light, is at a lower energy than red light. So we're not able to see it, but it is really useful because it happens to be the energy needed to make the bonds of molecules stretch and bend and wiggle. And each bond has a different amount of energy it takes to make it bend and stretch. And so by analyzing how much energy is being absorbed into the material, we can distinguish the materials from each other. And so as they pass that infrared light sensor, if we see the plastic we want, the airstream will blow air at the plastic we want and cause it to become a projectile and land into the bin on the right. And then all the other plastics will drop into the bin on the left. And this is done in iteration until all of the plastics have been separated from each other. And so once they're separated, they're each sent to an individual reclaiming plant that specializes in recycling that specific plastic. And although each plastic recycling is slightly different, they do have some things in common. So if we think about the recycling of a water bottle has a label that's paper, it has ink on it, it has glue holding the label on. It has a lid, or the cap, that's usually a different plastic than the rest of the water bottle. So to separate all these different components from each other, the plastic is shred into these little pieces and then placed into water. And because each of the different components have a different density, they'll end up in layers. that can then be scooped out and either put into the trash or continue to be recycled. So let's say we want the red shards here. We want to continue recycling them. If we look at them on a molecular level, we'll see the chains are all intertwined and just as long as when we started. But in the recycling process, we need to heat these shards to get them into pellets. And in that process, our chains can be shortened, just like in paper. So just like paper, plastic is not infinitely recyclable. However, this process happens slower than in paper. So plastics can be recycled more times than paper can be. However, like in paper, because the shortening of the chains, these plastics have to be used in things of lower quality or lower value plastics, like water bottles or t-shirts. And if we look at how many plastics we've thrown out since the 1950s, we have thrown out 6 billion metric tons of plastic after only using them once. And only 9% of these have been recycled, and only 0.9% have been recycled more than once. So not only are we bad at recycling plastics, but we're bad at hitting the potential of what we could be doing with recycling of plastics. So the question is, what can each of us do to help recycling? If we have this recycling bin as an example, full of great recyclables like clean cardboard and nice plastic water bottles, and we throw in this dirty cardboard pizza box, this is what's called a contamination. And the more contaminations we throw in, like this dirty paper towel or this shoe that can't be recycled, this bin that was once all recyclables is now probably going to end up all going to the trash. Because at the recycling facility, it's much easier to just throw the whole thing out than to try to sort the contaminations from the good recyclables. So sadly, all those good things that could have been recycled are probably going to end up in a landfill now. So it's important to wash your recyclables because food is considered a contamination, but it's also good to know what can and can't be recycled. So I have a paper cup here, a plastic water bottle, and a styrofoam container, and a plastic bag. And if you guys want to send me your guesses about what can and can't be recycled here, let's say send me your guesses of what can be recycled. That would be awesome. I don't know how this works. You guys just send them to me. I see plastic water bottle, cup, third and first, everything except styrofoam. Someone said plastic, bag, cup. So these are a lot of great guesses. There is a lot of plastic here, but actually the only thing that can be recycled is the plastic water bottle, which is a surprise because the paper cup is paper, right? But because it has that wax coating, unfortunately, it's now trash. The styrofoam container, on the bottom, there might be a recycling symbol that says 6, but because of the way it's processed, it actually can't be recycled again. So it's a great thing to know that even though something might have a recycling symbol on the bottom, it doesn't mean it can be recycled. And that brings us to our plastic bag that I know I used to think they were recyclables, and I would put a bunch of recycling bottles and things like that in them and throw them into the recycling bin. But this is actually a huge problem in the recycling industry, that people do the same exact thing, put a bunch of great recyclables and just throw the whole thing into the recycling bin. But because that's a contamination, more likely than not, it's going to end up in the trash. So there are some things that are universally recyclable or not, but each city has different rules about what they do and do not accept in their facilities. So it's important to check your local website for those rules. But let's say you're in a place where you don't know the recycling rules. it's important to just think about, is it not recyclable? And if you don't know, it's better to just throw it out. And so in the end, these are great things that each individual can do, but there's also a great effort being done at schools like Cornell trying to improve the efficiency of recycling and make it easier to begin with. And so Luis and I are really excited about things like that, and we hope you guys are too. So with that, it's been great talking to you, and we'd love any questions you have about recycling or grad school or anything like that.
Great. Oh, thank you so much for the informative talk, Shelby and Luis. This is very informative. I'm learning a lot here. Let's see. So my name is Sana, and I'll be asking some of the questions, asking you some of the questions that our participants have for you. So let's see. So Irene is asking, since recycling saves energy, what else then could this saved energy be used for?
So there's actually a really interesting statistic that I found while going through this. The amount of energy we save from recycling aluminum cans in a year, or aluminum in a year, is enough to power all of India for that same year. So these are hugely beneficial. And ideally, I think, along with using that energy for other more productive things, we also want to cut back on the energy we're using, because right now our energy sources are coming a lot from fossil fuels, which are being burned and causing pollution and global warming. And that's actually part of what I'm doing, is trying to make energy storage solutions to help move us away from that.
Gotcha. Nice. Then that's amazing. Then how about, okay, so, and then Alwyn has another question about the water bottle caps. Then Shelby, you mentioned that water bottles sometimes are not recyclable. Is the cap recyclable then?
It depends what plastic it's made out of. Yeah, it just depends what plastic.
Gotcha. So it would be better to, the best to be to check with your local, like a recycling company, and then see what they have, what they advise. Right, because as you said, if you're in doubt, better to throw it away, to not to contaminate the whole box of recyclables. Makes sense. Okay, and let's see, what else do we have? Okay, so Vanya is asking, so you've taught us that papers can be recycled once, but then how do you know if the paper had been recycled already, and then where should we put it?
So usually what happens is, with the paper, the recycling people themselves, the people who are processing it, will be able to sort through that in their own processing. Actually, one of the things that you can do is, if there's really low quality paper, so newspaper, you can use like in gardens as a bed, or in industrial composting, because that cellulose is made out of sugars, right? And so those sugars eventually can just be broken down just like any other sugars can. Like you can't eat it, but like microorganisms see that and they think, oh, this is pretty tasty, and can break that down.
Oh, that's great. That's like a food compost kind of for them.
Yeah.
Oh, that's great.
I'm not recommending like putting cardboard in your garden, but like there is that connect eventually that can happen once it's processed to very short strands.
Ah, gotcha. Okay, and Renee is asking, is it important to clean up plastic containers and bottles before putting them in the recycling bin?
Definitely. So things like plastic and glass and metal are super easy to clean out before you throw them into the recycling bin. And it makes the whole recycling process after that so much easier. And like I said, sometimes if there's so much food that there's too many contaminations, and it could end up in the trash again.
Okay. Yeah. So
super great tip.
Gotcha. Okay. And then Mara is asking, oh, this is a bit more scientific, I guess. How does the organization of polymer chains change the rigidity of a polymer?
How does the organization of the polymer chains affect the rigidity of the plastic?
Right. Mm-hmm.
So the monomers, like I said, really affect the identity of the chains and how they can come together. So depending on if there's a lot of bulk on the sides of the chains, that can affect how they come together, depending on whether you have polar or non-polar elements in your chain. There are so many things that affect how those chains come together, and whether they can come in those nice crystalline regions, or if they prefer amorphous regions.
Okay, so it depends on the polymers too.
And if I can add to that, those amorphous chains can more easily slip past each other. So if you imagine like the kind of spaghetti analogy instead of bricks, like you can pull a strand of spaghetti out maybe, but a brick is a little harder to pull. And so if you're thinking about that plastic bag, like if you have a bunch of crystalline regions, when you pull that, if there's a lot of amorphous regions, it's just gonna pull right through. Whereas if you have crystalline regions, there's actually a lot of really interesting science that some of our collaborators do about what happens. But those crystalline regions will make it stronger in the bulk because those chains are harder to pull apart.
Okay. Thank you so much for your informative talk again. And then, wow, we have a lot of questions coming in, but then I think they should be answered via chat so we can move on to next talk. Thank you so much again, Shelby and Luis.
Thank you.
Thank y'all.